to my channel. So today we shall be looking at another Acing your technical coding interview question at two numbers. So you are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contain a single digit, and you have to add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zero except the number 0 itself. So that's pretty straightforward. 2 plus 5 gives 7, 4 plus 6, that's 10. So you carry over 1, 0. 3 plus 4, that's 7, that's 8. That's pretty straightforward. So we're sure that we have at least one node. Number of nodes in each linked list is at least 1. The value is guaranteed that the number does not have a leading zero. Good. So how do we approach this problem? A naive way of approaching this problem is just for us to take the two linked lists and start from the edge. Okay, 2 plus 5, we add, it gives 7. And as we are adding, we are forming a new linked list from there. 4 plus 6, but where the challenge is when we have carryovers. So when we have carryovers, we need to carry that over to the next one. So that means we need to take care of the carry. Okay, so that means to get a carry, we need to divide this by 10, and remainder will be our carryover. Okay, okay, the number of the remainder will be our result, because when we divide by 10, okay, then the value itself will be carried over here. Then we continue like that. So let's see how we can handle. The basic logic is in being able to handle the carryover. If not, it's just to add and form a linked list. So the straightforward way would have just been for us to just form a new linked list by saying, let's say the new hell will be equals to, we have a list node, so we can form a dummy list node. Let's say that's -9. So at the end, we just return the next of that. So while we walk through this, we want to also be sure that we have both nodes. So while there is L1 and there is L2, that is when we can do an addition. So we do an addition here, okay, here. So, and also we want to see if there is let's say one is longer than the other. If you have 2 4 here and you have 5 6 here, and we also need to undo that as well, because the remainder, let's say we say this is 7, this becomes 10, so this one we still have to undo this and put 5 here if there's no 3. So how do we undo those of variable length, just like we have here? It's a bit trickish, but so we want to declare a carry. So let's see. So we need a total to be equals to our L1 dot val plus L2 dot val, and we need to get the carry to be equals to, that is what we're carrying over, will actually be the total divided by 10. So the real total divided by 10 That's the carry. At the same time, the real value that we need to add, the element, or when we say the number we need to add to our linked list, will be the total remainder of 10. So we need those two calculations, and we need to advance our L1 to L1.next, and we need to advance our L2 to L2.next. So let's see how the logic is going to go. So we have let's use an example like this one so that we trace how to handle those logic. So here we have L1 and L2, so this is 2 and 5. It gives us 2 and 5. Okay, so what we're going to do is that we take these 2, we add it to 5, so this gives us 7, but it is a remainder, so this is better as a remainder. It's what we're going to use to form our list node. So the remainder, okay, so the remainder, it's what we need, but so actually we need L1.next to form a linked list node of the remainder. So that's what we need there. So we need the L1.next as the remainder. That's what we need. Sorry about that. So but what we can do, so once we have that, so we also need another dummy here, because once we have formed this, we need to also advance our L1.next this way. L equals to L.next. We need to advance that as well. So we may need a dummy. So shall we say head equals to this, so we just return head.next here because we have used that. All right, okay, so if we had that, we get a total is 7, and then we want to add the carry as well. So initially we expect our carry to be 0 because we want to bring in the carry. So we need to add the carry to this one as well, plus carry. So these are the tweaks. So initially it will be 0. Then we need to update our carry, because by the time we had, this is 7 divided by 10. Now there is no carry here, so our carry comes back to 0 here. Okay, because it's not divisible, that will give us 0. But here the remainder here is this, so it is the remainder that we are going to add from a new linked list. So that makes sense. So this is 7, so the carry here will be 7 divided by 10, and that will give us 0. So the carry is 0, and the remainder here is going to give us 7 divided by 10, so that will give us 7, and we form our linked list node of 7, and we advance that. So here we now have -9 then linked to 7. So at this point we have -9 and we have it linked to 7 this way. Okay, then we advance our L1, we advance our L2, so this one becomes 4 and 6. So 4 and 6. So we had 4 plus 6, 10. Then our carry previously is 0, so we have 10. So here we get our carry, which is going to be 10 divided by 10, and that is going to give us a 1. So our carry is 1, and our remainder when we divide 10 by 10 is 0. So this is going to be to 0. So we advance that. So this comes to 3 and 4. So this becomes 7, but plus our carry, this becomes 8. And this will now become 8 divided by 10. So the remainder is going to be 0 because we are dividing 8 by 10. And the carry will be 0 and the remainder will be 8. So we had our remainder and from a list there. So that works. So we advance this. So this one is none. Then we come to return the 708. But we need to look at cases when the length are different. What will happen? That's where we have. So if the length are different, I can just use this. Let's say the length are different. So how will it work? So again, we have 2 and 5. I'll just quickly run through that. 2 and 5. So this becomes 7. Carry is 0. So we divide 7 by this. So this one is going to give us the carry is 0. And the remainder will be 7. So we add 7 to that. Then we come back to take 4 and 6. So 4 and 6 will give us a 10. Plus carry is 0. So this gives us a 10. Then the carry will be 10 divided by 10. This gives us a 1. The remainder will be 0. So we had 10 divided by, so the remainder is 0. So we had 0 to that. So our carry is 1. Now, but we still have 3 now. But we don't have L2 anymore. So how do we handle that? Can we still handle that within here or after? I think we can handle it after. What we can do is we check if there is L1, then we just add the carry, whatever it is, to that, and we join it, and we check if there's L2, or if we say either of this, or we can handle, instead of saying hand here, we can say here. So either of these. So as long as we have this, is 3, but we need to now be able to check this. So we can use all, but here, before we can access the value, we need to check. We need to check. So that means our total, we now go this way. Before we can get our total, we say if L1 and L2, so if both of them is available, then this will be our total. Else if, we need to check that so that I won't run into, if there is L1, then our total, we just exempt the L2. We just exempt this. Else, we know that by the time we get here, then we must have only L2. So this we just exempt L1, because if there's L1 we must have captured it here. If both of them, we must have captured it here. So this will help us. So our time is up. So this logic should be able to help us to avoid running into accessing uh, running into index error if it doesn't exist. Then we still have our carry, then we continue like that. Okay, but what then happens if at the end of the day we are done but we have a carry of 1? We actually need to put that carry at the end of the linked list. So if we had the last two nodes and we have a carry of 1, we need that carry to be added. So how do we do that? So what we do is that once we are done with this link, we'll check if carry, that is if there is carry, then our L1, our L dot next will be equals to the list node of that carry. Assuming it. But if the carry is 0, then we don't need it. Okay. So we're looking at, let's say we have 5, 7 alone. So 5 plus 7, that gives us 12. So at this stage you must have added the remainder, which is 2, but we have 1. So, and we're done with the loop. So we need to check if there is and make that. Well, that's pretty long. So I think that should be correct. So let's try and run it and see what we have. Yeah, good, that works. So let's see another example. Yeah, that works too. So I'm particular about this one. Let's see this. Let's see. We do have a problem there. Yeah, so we need to also check here too. If L1, that's when we can move. And here too, if L2, that's when we can move. Just the same way we did this. That's when we can move. If not, we can move. Good. So that works. So let's submit. Good. All right. Thank you very much, and see you in the next one.